Let us discuss about the inventory control and inventory models, which are very important when we discuss about the material management. We all know that for a flexibility in operating system, the inventory is very essential. And inventory, when we discuss about inventory in companies, normally companies maintain three types of materials. One, the raw material inventory, and work in progress inventory, and the finished goods inventory. So the raw material inventories, they remove dependency between the supplier and the plants, because the raw material availability is very important, and the manufacturing process, if there is no sufficient raw material at a right time, that will bring in lots of confusions and becomes chaotic for the production process. And the work in progress inventories, they remove the dependency between the machines and the production line. So the finished goods, that remove the dependency between the plant and its customers. So every stages of inventories, irrespective of the kind of material that you maintain, there is always a dependency. So for every smooth production as well as supply to the shop floor, and the finished goods inventory to the customer, the inventory management and the inventory control takes a at par importance. When we discuss about the main functions, right, what would be the main functions of inventory normally that takes care of the smoothing out of irregularities in supply at various levels, right, very important. Shortage of materials, that will bring an halt in the production process, or even put the customer in waiting at the receiving end. And it also minimizes the production cost, and allowing organizations to cope with perishable materials, because you know how you are going to maintain your inventory according to the kind of material that you are going to maintain it. So when we discuss about the inventory decisions, right, the two basic inventory decisions are generally taken up by the managers, and when to replenish the inventory of every item that they maintain, and how much of an item they have to order when that particular item of that inventory, when it is to be replenished. When it comes to inventory, everybody discuss about the cost trade-off. We know there are three types of cost. One is the ordering cost, holding cost, and the total cost, right? So the holding cost is the carrying cost, and the ordering cost is how many number of times that manufacturing company that places an order for the material to the production site. So ordering cost, it all the costs that involves placing an order till you receive, and the holding cost till the raw material is being used by the company for the completion of the transformation process, and the total cost is put together of this both ordering cost and the holding cost. So if you see that in this diagram, so this chart graph explains about three types of cost here, and you can see the ordering cost and the holding cost and the total cost. You can witness here that the order quantity, when the order quantity is very less, right, when the order quantity is very less, the cost of order, the ordering cost is very high, right? Less order quantity, more ordering cost. And the inventory carrying cost is very less, because you are ordering at a very lesser amount or lesser item, so the carrying cost is very less. On the other hand, if you order high order quantity, and the ordering cost will be very less. On the other hand, the holding cost is very high, holding cost or the carrying cost is very high. So in such cases, we always find a point, this we call as an economic order quantity point, where the holding cost and the ordering cost are very equal. So the total cost curve, that represents the sum of the ordering and the carrying cost for each order size, and the order size at which the total cost is minimum, right? This is the minimum total cost. This is the line that tells about the total cost, and here the point where the total cost is minimum and where the holding cost and the ordering cost intersects, we call that as an economic order quantity, or we can call that as an optimum order size, right? And next one, very important, when we discuss about the inventory control, the models are very important to discuss about the different models of inventories. So the inventory models we can classify into deterministic models and probabilistic model. So you have a various deterministic model. So these are all the deterministic model that we use under the models of inventory. So we have few models, namely the purchase model with instantaneous replenishment and without shortages, and manufacturing model without shortages, and you have purchase model with the shortages, and manufacturing model with shortages. Let's go just one by one. So the very first one, what we are going to discuss here is about the purchase model with instantaneous replenishment and without shortages. So in this model of inventory, normally if you see the order of orders of each time, right, the orders of each size is always equal, and there is always a periodic interval. If you see the time, the t is here the duration or the periodic interval that you place orders between each orders. So if you see the size of the lot, the order lot, and the duration is always the same. So the item against an order or replenished instantaneously, and the items are usually consumed at a constant rate. So the purchase price per unit is the same irrespective of the order size. So here what are all a major item that we need to see. So here if I just say for this particular model, if I say, right, I have an I can just put across this kind of graphical representation. I would say it could be an annual diagrammatic representation, where I would say that D is the annual demand, and C naught be the ordering cost. This is ordering cost per order, and CC is the carrying cost per unit throughout the year, and P is the purchase price per unit, and Q is the order size. So I can say that how do I find out the number of orders for the year? So Q is the order size, so you know the annual consumption for the throughout the year. So D is the annual consumption, so D divided by the order size. If you just calculate this, for example, 300 is your annual demand and order size is 500, so 50, so 300 divided by 50, the number of orders would be 6, right? So this is how we calculate with the annual demand divided by the order size. The second one is the average inventory. Average inventory is what is an average? Like if I say that 50 is the order size, 50 by 2, 25 is an average inventory, and cost of ordering order. So D by Q into cost of ordering, so C naught. If you just with the number of orders into the carrying cost, if you calculate per order, you will get the cost of ordering for the entire year. If the same applicable here with an average inventory, you just have to calculate the average inventory into the carrying cost. You can calculate the cost of carrying for the entire year. The next one is the manufacturing model without shortages. As I said that if a manufacturing company that produces any component, right, if that component is the major component for the main product, then normally what happens, the companies normally produce that particular product on their own. If the company takes care of such corresponding model of producing their own, then we call that as a manufacturing model, right? So this model, when available with both with the shortages and without shortages, so the rate of consumption, if you find this kind of model where the manufacturing unit, when they have without shortages, if you see they have the uniform consumption of items throughout the year, and the cost of production per unit, if you see, is always the same on the production lot. You could have seen some of the items given here, R and K, K minus R, and T and T2. When we are discussing about manufacturing model without a shortages, few items that you need to understand. So here there is one period given. The period is called T1 period. So during this T1 period, the items produced, normally the items are produced, the K is the production rate, or you can say the number of units that has been produced per year, right? So for this T period, and the item K, the units produced per period, and simultaneously it is consumed at the rate of R for a period. So what you have to understand, right? So during this period, normally what happens, the inventory is built at the rate of K minus R. So you know that the rate of K is the number of items that is being produced, and R is the demand of an item, right? So during this period, normally the inventory is built at the rate of K minus R, and for the period of T, so this is where once the production starts and the material being used, we can call K minus R, where the items in the inventory are falling down. right? So you can say for the time period when the production takes place, for the units being produced, when the materials being used, the items falls down. So this is for the period of T1. So what happens in the period 2? The production of item is discontinued, but the consumption of that item is continued. So the inventory is decreased at the rate of R units. That's why we call K minus R. So production is being halted, but consumption is always taken place. That's why for this period we call K minus R. For this period it is just R. So this is about how periodically for T1 period, how the items are being produced with the usage of the material that is being stored in the inventory. And for one, there are two periods being given for just one for one cycle. You can say that one cycle. So how inventory is being maintained in this cycle. So you can say we normally for this manufacturing without shortages, we call that as an economic batch quantity. So it just goes on batch wise. So what would be the formula for this? So as I said, we have items like R, which represents the annual demand of an item, and K, that is the production rate of an item, and C naught is the cost per setup. So what is the cost per setup, and CC is the carrying cost, and P is the production per level. So EBQ, we have a formula, root of 2 C naught R divided by carrying cost 1 minus R by K. So if you just want to find out the T1 period, the quantity of the T1 period, just you have to identify the total quantity that is being used by the production amount, and T2 is Q into 1 minus R by K divided by R. So cycle time, you just add T1 and T2, you get the cycle time. So next one is the purchase model with the shortage. So in this model, normally the items on order, they are always received simultaneously and they are consumed at a constant rate. So you must two things you must understand, that the orders are instantaneous order and they are consumed at a constant rate. So the purchase price per unit, irrespective of the demand, it is always remains the same, and irrespective of the order size, it remains the same, and there is no stock. I said, right, it is with shortage, so there is normally no stock at the time of receiving request for an item. So and also it is assumed that it will be satisfied at a later date with a penalty, right? So this is called back ordering, right? You get an order and at later point you get the material to complete the order. We call that as an back ordering. So normally this operations, we have D, which is the demand for the period, then we have carrying cost, ordering cost, and the shortage. There is one terms that it is called shortage. So here when you start with the quantity, and as the production starts, the quantity conversion process takes place, the materials falls down, so there is a supply, right? So this is a period, if you take the supply for the items in the inventory, that falls down. So the production still takes place, but there is a shortage of material, and later at point of time it gets replenished. So the process goes on like this. So this is called back ordering, right? The production still continues, there is a shortage of material, right, for the period of T2, and it gets replenished at a later point of time. It is called back ordering. So this is with the purchase model. So here we say the Q represents the economic order quantity, and we can have the maximum inventory period and the maximum stock out. So here these are all the variables what we find here. The next one is the manufacturing model with the shortages. So already we have seen manufacturing model without shortages, and I told you, right, we had two period, K1 and K2, like how things would go in without shortages. But this model we are going to discuss about with shortages. So in this model, the items are produced and consumed simultaneously. So here we have a cycle time. So the rate of consumption of items is uniform throughout the year, and the cost of production also per unit the same, irrespective of production of the lot size. So stock out is permitted. So it is assumed that the stock out units will be satisfied from the units, so which will be produced at a later penalty. So this is also called back ordering. So whichever the item involves with the shortages, we call that as the back ordering. So you can see the model. So here we have given. So this also goes with economic batch quantity. So we have a R, K, C naught, CC, CS and P, which is similar to the purchase model with shortages. So this is about the models that we discuss in inventory. So further models we'll discuss in later videos.